Sport pilots and flight fans, welcome back. A couple months ago I passed a milestone, my first 1,000 hours in this Sting Sport light sport airplane. Anyway, I thought that now would be a good time to reveal some of the many safety and performance tips that I've gathered over this first 1,000 hours of flying. Some from my formal training and some just from logging the hours. So without further ado, let's dive into 12 safety and performance tips for the Sting light sport airplane. Okay, number one, and at the top of my list, use extra caution and diligence when in the killing zone. Now, you may think that the killing zone is down here where we are now, 150 feet above mean sea level. And that can be true, but what it actually refers to is a concept of time, from about 50 to 350 pilot hours. That's when you're most likely to have a bad outcome. Part of the problem stems from the fact that this is the time when we're most likely to think we're at one with and the masters of our airplanes. I know it happened to me. I had a bad landing at Lake Tahoe during this period and was very lucky to walk away from it.
My brush with death instilled a deep respect for the killing zone and the pilot hours beyond. Now I realize I'll never be the master of this airplane because there's something important that must be learned or relearned every day. Number 2, living checklists. We all know the value and importance of checklists. I've learned, however, that these must be dynamic, living documents, not set in stone. Checklist items may require change or need to be added or deleted. When I update a checklist, I include the revision date, retype it, and take it to my local copy shop for lamination. I'm on my 4th iteration of a cockpit checklist now. Number 3, fuel checks. During our pre-flights, most of us measure fuel level 2 ways, from the cockpit gauge and visually in the tank with some type of measuring device. I've also determined the usable fuel at various gauge positions. This is done by draining and refilling known volumes, then cross-checking the gauge in the air. Here, for example, although the gauge indicates the 20-gallon tank is just under half full, there are still 13.5 usable gallons remaining. I also drain the sump into a glass jar every day so I can easily see and remove debris and water and prevent it from ever reaching my carbs or even my gascolator. Number 4, weight and balance before every flight. With today's electronics and software, not doing a weight and balance before every flight is rather inexcusable. It's so easy and quick. Here on the Garmin 695, it's just a matter of calling up the weight and balance page and changing any weights changed since the previous flight, fuel, passengers, baggage, etc. And voila, you have instant calculations of moment, weight, and center of gravity. It serves to get you thinking about performance to be expected given the field elevation and weather factors you will be encountering. Number 5, altimeter attention. In my area, the en route altimeter changes can be dramatic over relatively short distances, especially in summertime. Failing to update the altimeter as you go can easily leave you flying 500 or more feet above or below where you think you are based on the original setting. Every time I'm on the ground, I dial in the field elevation. Then I always cross-check this to the local or nearest AWOS or ATIS. The two methods comparing closely in feet tell me that the instrument is probably working okay. Then as I fly on to my destination, I regularly update to the nearest altimeter station by radio or phone. Number 6, a turnback plan. A common headline. Witnesses said the airplane was sputtering, turned back towards the runway, then spiraled straight into the ground. I prepare for a possible turnback on every climb out. The last item on my checklist is to verbally state the turnback plan for this takeoff, this runway, right now. What minimum elevation will I need? A turn left or right? If the minimum isn't made, where am I going down? With chute deployed or not? By considering options with respect to conditions, my actions if power is lost should be automatic. So far it's working. I've made it back safely 4 times when power was lost due to debris in the carburetors. Number 7, autopilot. Yes. My opinion, the best optional avionics instrument is autopilot. Even a relatively simple single-axis unit like mine adds comfort, relieves stress and fatigue, and has other safety benefits. Need to take a whiz or study a sectional? Press the autopilot button. Current heading will be held. Pitch is maintained manually with the trim lever. Navigate to a waypoint. Enter it in the Garmin 396, then press the button again. Again, just maintain pitch. Disengage autopilot by pressing and holding the control button. Number 8, cold weather warm-ups. Getting the oil temperature of a Rotax 912 series engine up to the minimum 120 to 122 degrees can be problematic in cold weather. However, if there's wind, it can help you. Try a long taxi with the wind hitting the propeller from behind. Or simply turn and stop at the run-up area with the wind from behind. You'll be surprised how much quicker wind from behind warms an engine. This applies to hot weather too. Number 9, stabilize ignition checks. Detecting ignition anomalies is easier with stable, consistent ignition drops. Drop variation can be reduced 2 ways. First, always do tests at the same oil temperature. I prefer 128 degrees based on nearly 1,000 run-ups. Second, always test ignitions with the airplane and propeller directly into the wind. A cross or trailing wind causes variability and should be avoided. Number 10, counter performance robbers. We know the 3 enemies of aircraft performance: hot, high, and humid. Experiencing them is what makes us true believers. Now I don't hesitate to remove weight when I have to, whether it be a passenger, fuel, or just stuff. But the biggest thing I've learned in 1,000 hours is to study weather religiously in relation to density altitude, then make my flights at times of day and seasons of year when risks from the 3 H's are lowest. 11. Manage climb out throttle. Wide open throttle on climb out is hard on engines and leads to overheating. To reduce heat and wasting fuel, at about 800 feet AGL, I pull the throttle back just slightly until a small RPM drop occurs. Then I climb a few hundred more feet and throttle back more until I find the sweet spot of the hottest EGT. The sweet spot is where the EGT falls quickly by 20 to 50 degrees. I hold it here during the rest of the climb out, and the engine oil and cylinder heads soon cool too. The sweet spot method also works for straight and level flight. Number 12, avoid propeller harmonics. Sometimes as throttle is reduced, prop unloading causes vibrations or harmonics. Harmonics arise most during steeper descents, cross or following winds, high altitudes, and rapid throttle pullbacks. Avoiding harmonics by management of flight characteristics and throttle changes reduces wear on the engine mounts, and gearbox. If flight management fails to minimize harmonics, look for an issue with the propeller, such as damaged, loose, warped, or out of balance blades. Thanks for watching. Browse my other videos at Sting Flight and subscribe. It's free.